Assalamualaikum. My name is Fawazuddin bin Soain. My metric number MH20022. I will introduce our project is Produa Kancil 66ES. Okay, for our engine specification is the engine is 660ES. The capacity of the engine is 659 cc and bore is 80. For bore is 68 millimeter and stroke 60.5 millimeter. Compression ratio is 9.5:1. Cylinder 3 inline. Maximum power is 22.8 kilowatt at 6,400 rpm. Then maximum torque is 49 newton meter at 3,200 rpm. Then full tank capacity is 32 liters. For connecting rod, center to center length is 122.7 millimeter and inner diameter for small end is 18 millimeter. Then lastly, the inner diameter for big end is 42.8 millimeter. Okay, thank you. That's all for me.
Assalamualaikum and very good day. My name is Muhammad Shafidas bin Nazruddin. My metric number is MH20009. I'll be presenting about piston analysis. Piston design must have the following criteria: high strength, minimum weight to sustain inertial force, accurate dimensioning to operate as an efficient oil sealer in the cylinder, and enough support for the piston pin. For the analysis, we use AutoCAD and ANSYS. For AutoCAD, these programs are able to precise construct model in both 2D and 3D. For ANSYS, this is the example of ANSYS workbench modeling process with finite element method analysis. For the goal of numerically resolving a wide range of mechanical issues, ANSYS is a general purpose finite element modeling program. That's all from me. Thank you.
Hello, my name is Iqbal, ID number MH20019. So I will continue to the Excel data that will generate the value and the graph. So we use 660EX engine from Produa Kancil. So to generate the value and the graph, we just put the specification of our engine. Next, we continue to the pressure versus volume graph, where we just got the maximum pressure of our engine is 18.9 at 89.3 cc. Next, the pressure versus crank angle graph. So the peak pressure placed near to the TDC, which is mean the force generated can be utilized efficiently for our engine. Next, the graph we just generate is fuel deliver versus crank angle. So the graph generated by the specification we key in the Excel. So that's all from me. Thank you.
My name is Muhammad Nagiuddin bin Muhammad Nazri. I will explain about kinematic analysis. Engineering designs aims to create systems that won't malfunction for the duration of their intended service life by keeping stress within acceptable limit for the selected material and the environmental condition encountered. The definition and management of all system force are plainly required by this. We can see the kinematic calculation of the piston. We need data. Our data is R equal to 30.25 millimeter, and we need assume to the angle. Our angle is 75 degree, and our N is 6,400 rpm. We need also the omega. Our omega we get from this formula, and our omega value is 670 and 0.2064 rad per second. We can see this is formula to get the displacement. We can also get the displacement from using Excel. We just key in like this in the Excel, and our answer is 112.441 millimeter. This is our displacement graph. You can see. Now we see the how to get the velocity. This is the formula. You can see. This is formula for using the Excel. From the Excel we get the answer. The answer is negative 20.8325 meter per second. This is our velocity graph. It's stable for the piston. Next we show you the acceleration graph. Before that we need to find the x double dot. This is formula, and we also use the Excel to get the value of x double dot. We just key in the Excel, and our result is negative 615.686 meter per second square. This is the acceleration graph. You can see is suitable for the piston.
Hi, Assalamualaikum and a very good day. My name is Muhammad Waqif Ghazali and my number is MH20011. Okay, for this I will take the dynamic analysis. Okay, kinetic error of roller Kancil is 0.5 kilogram and we assuming moment of inertia is 50 gram per meter square. Okay, so for our dynamic equilibrium system, we use the formula L1 times L2 equal to radius of gyration square. So L2 will take equal to 100 divided by 88 equal to 1.136 mm. So M1 is misplaced at the small n center, M2 misplaced at the distance L2 from the center of gravity G. So M1 and M2 we want to find it. So M1 L2 times M divided by L1 plus L2 equal to 0.0627. So for M2 we get 0.4936 kilogram. So if we sum up of it, we will get 0.5 kilogram. So that's all for me. Thank you.